Think math.
Multiplication drawn as a picture is a rectangle. Width 3, height 4, and the area is 12. Letters work the same way. A rectangle of width x plus 3 and height x plus 2 has area x squared plus 5x plus 6. So factoring becomes this. You know the area, and you have to recover the width and the height. Let's break x squared plus 5x plus 6 into pieces. One square with side x, 5 long tiles, x by 1, and 6 small squares with side 1. Add up the areas of all the pieces, and you get the original expression exactly. Now let's push these pieces together, with no gaps, into a single rectangle. Put the big square at the top left, then split the long tiles between the right side and the bottom. 3 on the right, 2 along the bottom. That leaves a gap in the bottom right corner exactly 6 cells wide, and the 6 small squares drop straight in. No gaps and nothing left over. The finished shape is a rectangle of width x plus 3 and height x plus 2. Now read the picture. You can write the area of that one shape in 2 different ways. Count the pieces, and you get x squared plus 5x plus 6. Multiply width by height, and you get x plus 3 times x plus 2. Those are just 2 descriptions of the same area, so of course the 2 expressions are equal. And that is exactly what factoring is. The picture shows one more thing: why some expressions simply will not factor. Change the number of long tiles however you like. Once you split them between the right side and the bottom, the space left over has to match the number of small squares exactly, or the rectangle never closes. If it does not match, you are left with a gap. That is why not every expression splits neatly. Next time, we will see how to find those 2 numbers that do fit. Factoring is rebuilding a rectangle out of scattered pieces. A sip of math every day, here at Think Math.